What happens when space becomes too crowded? The vast expanse of space, once thought to be infinite and empty, is now bustling with activity. Satellites, space stations, and various spacecraft are all vying for their place in Earth's orbit. But with this surge in space activity comes a significant challenge. The more we send up, the more crowded it gets. And this congestion isn't just a minor inconvenience, it's a ticking time bomb. Spoiler, it's a disaster waiting to happen. Imagine the chaos of a busy highway, but in space. A single collision can create a cascade of destruction, sending debris hurtling in all directions. This isn't just theoretical, it's a very real and present danger. The aftermath of such collisions can be catastrophic, not just for the equipment involved but for future missions as well. For decades, we've launched rockets and satellites into space, each mission a testament to human ingenuity and our desire to explore the unknown. From the early days of space exploration to the modern era of commercial spaceflight, our presence in space has grown exponentially. Every launch, every satellite deployed, adds to the intricate dance of objects orbiting our planet. Each mission leaves its mark. The remnants of these missions, from spent rocket stages to defunct satellites, remain in orbit long after their useful life has ended. These pieces of space history, while fascinating, pose a significant risk. They are the silent witnesses to our progress, but also the harbingers of potential disaster. We rarely think about the remnants we leave behind, out of sight, out of mind. But these remnants, often referred to as space junk, are accumulating at an alarming rate. Each piece, no matter how small, has the potential to cause significant damage. The sheer volume of debris is staggering, and it's only getting worse. But these remnants have a name: space debris. Space debris includes everything from tiny paint flecks to large defunct satellites. These fragments, traveling at incredible speeds, can turn into deadly projectiles. The term debris might sound harmless, but in the context of space, it represents a growing menace. Space debris is more than just trash, it's a growing threat to the future of space exploration. As the number of objects in orbit increases, so does the likelihood of collisions. Each collision generates more debris, creating a vicious cycle that could eventually make certain orbits unusable. This phenomenon, known as the Kessler syndrome, is a scenario we must avoid at all costs. It's a growing threat to the future of space exploration. The International Space Station, for example, has had to perform numerous maneuvers to avoid potential collisions with debris. These evasive actions, while necessary, are not a sustainable solution. The more crowded our orbit becomes, the more challenging it will be to ensure the safety of both manned and unmanned missions. Imagine a bolt traveling at thousands of miles per hour. This seemingly insignificant object moving at such high speeds can become a deadly weapon. The kinetic energy it carries is enough to cause catastrophic damage upon impact. In space, even the smallest objects can have devastating consequences. This bolt could cripple a satellite. A single collision can render a multi-million-dollar piece of equipment useless. The financial implications are enormous, but the ripple effects on communication, navigation, and scientific research are even more profound. The loss of a satellite can disrupt services and hinder our understanding of the universe. It could even threaten the lives of astronauts. The brave men and women who venture into space face enough dangers without the added risk of space debris. A collision with even a small piece of debris can be fatal. Ensuring their safety is paramount, and that means addressing the issue of space debris head-on. This is the reality we face as our orbit becomes more congested. The dream of exploring space comes with responsibilities. We must find ways to mitigate the risks posed by space debris. This includes developing technologies to track and remove debris, as well as implementing policies to prevent further accumulation. The future of space exploration depends on our ability to manage this growing problem. The cosmos may be vast, but our immediate orbit is becoming increasingly crowded. It's up to us to ensure that space remains a frontier of opportunity, not a graveyard of our past endeavors. Space debris isn't always large and easy to spot. When we think of space debris, we often imagine large defunct satellites or spent rocket stages drifting aimlessly. However, the reality is far more complex and insidious. In fact, much of it is tiny. These minuscule fragments, often no larger than a grain of sand, are the remnants of larger objects that have collided or disintegrated over time. They may seem harmless due to their size, but they pose a significant threat to space operations. We're talking about flecks of paint, metal fragments, even frozen coolant. These particles originate from a variety of sources, including chipped paint from spacecraft, fragments from exploded satellites, and even frozen droplets of coolant from leaking systems. These particles may be small, but their speed makes them incredibly dangerous. Traveling at velocities of up to 28,000 kilometers per hour, even the tiniest piece of debris can cause catastrophic damage upon impact. Imagine a sandblaster stripping away at a spacecraft. The high-speed particles act like a relentless barrage, eroding surfaces and compromising the integrity of critical components. That's what even tiny pieces of debris can do. They can create pits and craters on the surface of spacecraft, weakening the structure and making it more susceptible to further damage. They can damage solar panels, puncture hulls, and disable sensitive equipment. Solar panels, which are essential for powering spacecraft, can be shattered by these high-speed impacts, leading to a loss of power and functionality. And the worst part? Tracking these tiny fragments is incredibly difficult. Despite advancements in radar and optical tracking systems, the sheer number and small size of these particles make it nearly impossible to monitor them all. They're like bullets, whizzing through space unseen. Invisible to the naked eye and often undetectable by current tracking technology, these tiny projectiles pose a constant and unpredictable threat to both manned and unmanned missions. To mitigate this risk, engineers are developing advanced shielding and protective measures. These innovations aim to absorb or deflect the impact of small debris, safeguarding the spacecraft and its mission. Regular maintenance and repairs are also crucial. Astronauts often have to perform spacewalks to inspect and fix any damage caused by these tiny yet potent threats. As we continue to explore and utilize space, addressing the challenge of space debris becomes ever more critical. Future spacecraft designs are increasingly incorporating features to withstand these impacts, ensuring the safety and success of missions. The unseen threat of space debris is a reminder of the delicate balance we must maintain as we venture beyond our planet. By understanding and mitigating these risks, we can protect our spacecraft and ensure the continued exploration of the final frontier. In 1978, NASA scientist Donald J. Kessler proposed a terrifying scenario: the Kessler syndrome. Imagine a chain reaction in space. One collision leads to another, creating more and more debris. This debris then causes even more collisions, and the cycle continues. This isn't just a science fiction plot, it's a real possibility. As we launch more objects into space, the risk of the Kessler syndrome increases. If it happens, it could trap us on Earth, cut off from the benefits of space. Right now, there are thousands of trackable objects orbiting our planet. These include defunct satellites, spent rocket stages, and fragments from past collisions. But the real danger lies in the millions of smaller pieces we can't even see. Think of it this way: we've created a massive junkyard in space. And like any junkyard, it's only a matter of time before something goes wrong. We need to clean up this mess before it's too late. Section 5, ESA's Clear Space 1, a giant claw in space. Thankfully, we're not just sitting idly by. Around the world, brilliant minds are working on solutions to the space debris problem. One promising project is the European Space Agency's Clear Space 1 mission. Clear Space 1 is essentially a giant claw in space. Its mission to grab a piece of space junk and drag it back down to Earth. This may sound simple, but it's incredibly complex. It requires pinpoint accuracy and advanced robotics. Section 6. SpaceX's Starlink, avoiding a cosmic traffic jam. SpaceX, the company known for its reusable rockets, is also tackling the space debris problem. With the increasing number of satellites being launched into orbit, the risk of collisions and the creation of more space debris has become a significant concern. SpaceX, however, is not just focusing on getting their rockets to space and back. They are also deeply invested in ensuring that space remains a safe and sustainable environment for future missions. Their Starlink constellation, designed to provide global internet coverage, could have added to the problem. With thousands of satellites planned for deployment, the potential for a cosmic traffic jam was real. However, SpaceX has been proactive in addressing these concerns. They have implemented several measures to ensure that their satellites do not contribute to the growing issue of space debris. But SpaceX is taking steps to prevent this. They have a dedicated team of engineers and scientists who are constantly monitoring the satellites and the space environment. This team is responsible for ensuring that the satellites operate smoothly and avoid any potential hazards. They use advanced tracking systems to keep an eye on the satellites and the debris around them. Starlink satellites are equipped with advanced sensors and propulsion systems. These sensors can detect nearby objects and potential collisions, allowing the satellites to take evasive action when necessary. The propulsion systems enable the satellites to change their orbits and move out of the way of any incoming debris. This technology is crucial in preventing collisions and ensuring the longevity of the satellites. This allows them to dodge potential collisions. The satellites are programmed with algorithms that can predict the paths of nearby objects and calculate the best course of action to avoid them. This predictive capability is essential in a crowded space environment where even a small piece of debris can cause significant damage. They can even automatically maneuver out of the way of debris. This autonomous capability means that the satellites do not need constant human intervention to stay safe. They can make real-time decisions based on the data they receive from their sensors, ensuring that they remain in optimal positions and avoid any potential threats. It's like having a cosmic traffic cop, keeping things moving smoothly. This system of automated collision avoidance and real-time monitoring ensures that the Starlink constellation can operate efficiently without contributing to the space debris problem. SpaceX's efforts in this area are setting a new standard for satellite operations and helping to pave the way for a safer and more sustainable future in space. Section 7. Innovative solutions, from nets to lasers. Clearing up space debris requires creativity. That's why scientists and engineers are exploring a range of innovative solutions. Imagine giant nets capturing debris like fish, or powerful lasers nudging debris out of orbit. Some researchers are even developing space tugs. These robotic spacecraft could grab onto debris and tow it to a safe disposal location. The possibilities are as vast as space itself. Section 8. A call for global action. The problem of space debris is too big for any one nation to solve alone. It requires a global effort. We need international cooperation, shared responsibility, and a commitment to sustainable space exploration. Just as we've come together to address climate change, we must come together to protect the space environment. Our future in space depends on it. Section 9. Safeguarding our future in space. The quest to explore the cosmos is one of humanity's greatest endeavors, but we must proceed with caution and responsibility. We need to clean up our act in space before it's too late. Imagine a future where space is a shared resource, free from the threat of debris. A future where generations to come can continue to marvel at the wonders of the universe. It's a future worth fighting for,